Now the topic is Gpib, General Purpose Interface Bus. What is called a bus? Bus is simply a bunch of wires that it is used to transmit or receive data. That is called a bus. Here we are going to see about what is called a Gpib, RS-232 and USB. Okay, these are all buses or bus standards for measuring instruments, not only for measuring instruments, interfacing a computer with any other peripheral devices by using a Gpib RS-232 USB. First we can see about what is called a Gpib, General Purpose Interface Bus. Its pinout is shown here, and then it consisting of 24 pins. It is mainly used to connect a PC and measuring instruments. Gpib basically consisting of 8 data lines, 3 handshake lines and 5 management lines. See, this is the pinout of a Gpib, that is having a 8 data lines, that is 1, 2, 3, 4 and 13, 14, 15, 16th pins are totally that it is a 8 data pins. Okay, then this is the pinouts of a Gpib. Then handshake signal is at the pin number 6, 7 and 8. Management pins are 5, 9, 10, 11, 17. And then ground pin is 12. And then these are all also ground. I mean, this is a logical ground. These are all the ground regarding with the concern pins. Okay. We can see about the data lines. Gpib is a 8-bit data. Transmitting and receiving pins are from DIO 1 to DIO, that is a data input output 1 to 8. They are 1, 2, 3, 4, 5, 1, 2, 3, 4 and 13, 14, 15, 16. These are all actually it transmit a 8-bit data. Okay. Then handshake pins 6, 7 and 8 are handshake pins. What is called a handshake? Suppose that it is transmitting a data between a computer and any peripheral device or instrument, any instruments, that it has to make a handshake signal or to make a correspondence between these two devices, whether the data is available or the data which is available in the data bus is a address or commands like that. For that, these are all that informations are available here. First one is a DAV, data valid. This signal is used to the signal line that indicates that the data is being sent. NRFD, not ready for data. It indicates that the device is not ready to receive data. If already the device is busy with the previous data transmission, it shows that it indicates that the device is not ready to receive a data. Then NDAC, not data accepted. It indicates that the data not been completely received. Still the process is going on. It indicates that the data not been completely received. Okay. And then remaining are the management pins 5 lines. They are 5 management pins are EOI, IFC, SRQ, ATN, REN. We can see for the first one, EOI, end of identify. The end or identify, this pin is used to communicate between transmit and receive, whether the data is transmitted or received completely. It is used to identify the end of transmission or reception of the data. Whenever the starting of the transmission, receiving of the transmission, this will give the indication. This pin is used to communicate between transmitter and receiver, whether the data is transmitted or received completely. Okay. Then next one is a IFC, interface clear. This pin is used to send a signal to initialize the interface function on all devices. Whenever the device receives this signal and reset the interface function to their initial stage. So this pin is initiated that the device that it went to initial stage or starting condition. Okay. This pin is used to send a signal to initiate the interface function to on all device. Whenever the device receives this signal, reset the interface function to their initial state, that is device went to initial condition, that is a starting condition. SRQ, that is a service request. In a computer, many number of devices or instruments are connected with the computer. This pin signals means when the SRQ is low, the controller investigate which device made the request, which one is made a request. Based upon that, the processor or the computer that search for that device, and then that will satisfy the service requested by that particular instrument or accessory devices. Okay, what kind of the service is required. Then ATN, attention. The ATN is used to identify the command mode or data modes. If ATN is low, the bus DIO to DIO 8 is in command mode. If ATN is high, the bus is a data mode. So already I told that 8 pins of the data, 8-bit transmission is there in Gpib. If the data which is available in data is a command, or either it may be data or it may be an instruction. If it is a high, means the bus having a data. If it is low, means it may be a address, or it may be any command, or it may be any instruction. That is called a command mode. Okay. Then REN, remote enable. It is used to control a remote or local status of the device. The corresponding ground pins, the twisted DAV. The 18th pin is a ground for DAV, 19th pin is a ground for NRFID. Correspondingly, remaining pins are twisted ground for corresponding pins. Then advantages. Simple hardware interface allows a mixing of slow and fast device. This is a massive and rigid and robust in connection. Disadvantage: high cost, limited availability, mechanically bulky connectors and cables, lack of command protocol standards. That's all.